Okay.
Let's see, can I switch to the Hangout screen so that if your actually voice is recognized, your PF should show up. Yeah, not yet. See, yeah, there we go.
Okay. Well, for anyone listening live from somewhere else, you're going to have no context, so sorry.
Just give them like a 5 minutes. This is getting recorded, so.
All right.
It's like 5 minutes worth. That's all I ask.
Okay, so I'll repeat a little bit of context here. So we're talking about getting classes out of Jenkins core that didn't belong there. And so as an example, we're talking about a split of the JUnit plugin. Historically, all of this code was this Hudson Tasks package. This used to be part of Hudson core, so this is all stuff that was underneath here. And you can see that there's still some stuff in Jenkins core that doesn't really belong here, like the Maven builder here. So that's something that's still to be done. But we're talking about something that did get split out before, so the JUnit plugin. There's some metadata recorded in this classic plugin strategy, which is part of core. It has this list of all of the plugins that were ever split out. And each element in the list is a plugin that was removed. The core version right before the removal. So it was removed between 1.577 and 1.578. And the version of the JUnit plugin that was released as part of the removal, where the new packages were extracted to. So if your plugin had a dependency, if you had some other plugin that has a dependency on Jenkins 1.578 or newer, which is most plugins at this point, I hope, then it's not going to have any way of referencing any of these APIs like abstract test result action unless it declares an explicit dependency on the JUnit plugin. But a historical plugin that had a really old baseline like 1.565.x or something like that, since we don't know whether or not it happened to have been using any of these APIs, for the sake of safety, we have to assume that it did, so that we don't get linkage errors when people upgrade Jenkins core. And so those plugins will get what we call an implied dependency on JUnit version 1.0. So that means that they're able to link against JUnit plugin classes. And as far as plugin manager is concerned, and the update center and everything, it actually has that dependency. So.
Yeah, question.
Yeah.
So why was this method chosen over, say, you're looking at a plugin that has a baseline before the switch, right? And so you're assuming that at some point the JUnit plugin, some other plugin that's being installed may be depending on the JUnit plugin. Mm-hmm. Was there any reason why you went this way and not, say, some static analysis of the plugin being installed to kind of guess what it relies on?
So the question is whether he could have done like bytecode analysis or something like that. Possibly. I mean, there are probably a few cases where something doesn't show up in bytecode but still a dependency. But yeah, that would probably have been possible. We didn't implement that.
Okay.
It would have been somewhat more complicated to do, I think. Mm-hmm. At any rate, so we set it up this way. So, so if you have really old core baselines, you might wind up with a bunch of these implied dependencies, which get cleared automatically as soon as you update to a modern version of Jenkins. Once in a while, this causes weird problems with dependency cycles, which currently we work around with a special way of breaking those cycles that's hard-coded into core. There's an RFE to let you do this better, basically by having the depending plugin declare that even though it has a really old core baseline, like say 565 in this example, it does not in fact include JUnit. So that's one thing we could do, or we could try to switch to the bytecode analysis instead. In terms of the process of this, it's kind of complicated because basically, as I was showing here in this example, pull request 2352 that's in progress to extract the Maven builder. Sort of the first stage was doing a bunch of reorganizations. You can see that most of this patch is actually moving files around, so that we're moving files out of the core part of the source tree into a new temporary plugin in the Maven reactor. That's just to test the effects of making it into a plugin without having a git diff, which is basically like delete all. And that's kind of important for purposes of merge conflicts, because if this is still in progress, as this has been for like years now, people are making other changes to classes in those packages, and the only way you're going to not have merge conflicts is if you only did a rename. So this makes it possible to merge periodically against master. So basically, as soon as the extraction part is done, where you're breaking the code level dependencies, then the next step would be to physically delete these sources from core. You copy them into a new repository with plugin packaging. They have to get added to the Jenkins CI org and all of that stuff. And then basically in your new plugin, you declare a baseline as new as you can, but no newer, which in the case of JUnit, basically the baseline was 1577, if I remember right. And release it, and then you mark that released version in the classic plugin strategy list. So when the next weekly goes out, it marks it as a detached plugin. So these do not necessarily get installed at all. So I mean, they could be included in the setup wizard, but they don't need to be. They're just there again so that old plugins would get an implicit dependency on them, so that they'll still link. We go back to the 1.0 version of the Jenkins. Let's see, did I do anything interesting here? Let me just go to the JUnit 1.0 release and look at the POM for that. So you can see that we're, as of the 1.0 release, we're depending on a pretty recent version of core, but in order to cut a Maven release, you have to have dependencies on releases only, not on snapshots. So you actually have to pick a recent core baseline. So that means that there's sort of this window whereby someone running 1575 or 1576 or 1577 could, if they were dumb, they could install this plugin and then have 2 copies of the code, which is not very good, but it's hard to, we're not sure how to avoid it, except maybe using like beta release versions or something. And then as soon as it's practical, so here's like a few days later, maybe it's 1577 included the split rather than 1578. Okay, I guess this is actually sorry. So this is the new version of core that doesn't include it, I suppose. Whereas 1576 still included it. Maybe that's it. At any rate, so once 1577 was actually released, so it's a few days later, you wait for the weekly release to appear, then it's a good idea to update the core dependency and cut a fresh release. That makes sure that it's not going to show up in the update center for people using old weeklies. So it won't really matter once the next LTS comes around, but for people in that critical window, you want to make sure they don't accidentally install 2 copies of the same code. So you have to do this dance where you do a double release like that. So that's sort of the mechanics of the packaging and moving stuff around. But the interesting part is the actual splitting, so the actual kinds of refactorings that you would do to make it possible for something to be a new plugin. So if you're lucky, all of the code that you're trying to split is purely a set of extensions, so stuff with the add extension annotation that refers to some other classes and resources and stuff, but with no inbound dependencies. So if you're in that situation, then everything's fine because you just move all of those files to a new plugin and you're done. As, Jenkins has declarative registration. There's no master list of all builders or anything. It's just, if there's an add extension, then it adds it. So those are the easy cases. But let's go to the time when this was actually added here. So you have a little NetBeans shortcut to jump to the GitHub web UI for a given line of code, which is pretty handy because then you can use blame and jump to the commit that created it and so on. Actually, it's even edited it a little bit differently. So, oops. Actually, I have to go to maybe the line above it. No, maybe I can't. Actually, I'll just go to history because it's gotten rewritten a few times since.
You can go to the blame before the linked commit. Do you know that feature? It's pretty new.
Oh yeah, yeah, that would be useful. But probably easy.
It exists, so you can just go back.
Okay, at this point, it's probably easier to just find it, which is here. Yeah, so here we have the actual commit, moving it to a plugin. So here we're adding the split entry, and you can see that this was first released in Jenkins 1.577. It's the first tag containing this. So lots of comments here, but so you can see that most of it is just deleting all of these files, which is fine. Right. So these files are just copied over verbatim, and that's about it. But how do I get the list of the detailed list of changes? It's not showing a summary here. But you can see that in this case, there are actually some other changes that needed to be made because of anti-modular patterns. So, all right, so there are some cases that are pretty obvious, like, somebody used @link in Javadoc. Well, okay, if you just want to give an example, you can use that code, so it compiles. So that was pretty easy. There's a lot of cases like that where it was just a Javadoc reference. But the interesting bits are, let's go to get aggregated test result action and abstract build. But at some point, somebody thought it would be a great idea to have this helper method that just delegates to get action, except it's pre-populated with the class that you're getting. So this gets the test results for a given freestyle type build. Totally useless method as it turns out. I mean, it's not even necessary even for type safety because get action takes a type parameter, so the return type is well typed to the type that you're asking for anyway. So basically a completely useless method, but it caused all kinds of mayhem when we wanted to remove this thing to a plugin because now you can't have this method in core referring to a type that core can't link against. So you had no really good solution to it. I mean, I put in some reflection here so the method would still exist and return the same value, but it doesn't really help very much because any plugin that was actually linking against that method is going to wind up having a linkage error anyway. So if you get into a situation like that, you're just kind of out of luck, you have to accept that there's going to be a binary incompatibility. And what you need to do for that is, see if I can find some example of this. Actually, it's a search. Search in different plugins that might have called that method originally. Here's one, I think. Yeah. So here's how you should be calling it. Make it a bit smaller, try to get it to fit on screen. So that's a perfectly reasonable invocation. So if you're able to link against the JUnit classes, then you can make this call, and it's well typed. But it's possible that the, well, who knows what the original call was. There were a bunch of cases where people were actually calling the build.getAggregated test resolve action. And I don't know if this is one of them. It's deprecated code. Yeah, it looks like this is one of them. Yeah, so originally it was calling this anti-modular method, and so it just had to be refactored to call the new one. So if you get into this situation where you have to break compatibility, basically you're going to have to search Jenkins CI org for everyone who is using it, fix them up, and make sure that they get a release, so that, at least for all of the important plugins, so that when people do update Jenkins core, they're not going to get linkage errors, assuming that they've also updated the plugin that you're patching. So that's kind of a tricky case. And let's see, extension point. Let me see if I added any extension points in this one. No, I didn't. Sometimes there is a case, I'm trying to think of a example offhand. I think there's one in matrix projects. In the matrix project split, let's see if we can find that one. Now Daniel's special trick might be useful. So this is the blame view, and I'm
The blame, there's a
Yeah.
right
Yeah,
next
there's
to
that
the-
button.
END. Yeah, so that's something new.
Yes, you got that.
Yeah. Oops.
Did you click the right one? The one underneath.
It's impossible to see anything at this resolution.
Yeah.
touch list.
Touch the list. Yeah. Okay. What do I click on it?
Yeah, you click on it and it takes you to the change prior to that. So you search.
Oh, I see. Yeah, yeah. Right.
Right.
So you need to find when the matrix project one was added. So it's prior to this one.
No, it's split up. Oh, matrix off.
Yeah. Matrix project.
Oh, matrix project.
Yeah.
Sorry.
So in this case, that's handy. Okay, yeah. So matrix project 1.0. All right. So this was split off sometime before 1.565. Yep, that's right. So okay, so there's actually something even a bit before this one. And I'm going to view history and find the previous change. Preparing to include, yeah. So here we go. Actually have a pull request here, extract matrix project. There we go. So in this one, yeah, so we're adding the matrix project attached one. We're changing some Java doc and that sort of stuff. Here's a case where someone was saying like instance of matrix project. So that's something that you can do by just checking class name instead. You don't actually have to link against that type in order to do it. So that was a pretty easy fix. There were deleting some stuff. So for all the stuff that we're deleting, then these yellow boxes are the things we had to patch. So that's the interesting bits. So, okay, so here we have some Java doc, that's the usual. Here we had some xstream aliases, basically a static initializer that set up some aliases for these things in XML configuration files. That's easy enough. We just move it to a static initializer in the plugin. But this, if I remember right, this was a real problem. So we originally had this class parameters action, which is sort of a generic type in Jenkins core that's used for all sorts of purposes. And it originally implemented this marker interface called matrix child action. And that's going to be a problem because you can't have something in core implement a marker interface from a plugin. So in those cases, you have to be somewhat more clever about. And then there's another case here with the JUnit result archiver. Used to implement this marker interface matrix aggregatable. This was actually the one they was thinking of. And that defines a new method, create aggregator. So here you have a case where something that you're trying to get out of core is actually defining mix-in interfaces that were originally implemented in some core class, much more generic than this new plugin is, that have signature dependencies on the things you're trying to extract. So that obviously needs to be deleted. You can't have it there. So the question is, what do you do in place of that? So we had to retain this behavior, whatever that was. Right? So this was in JUnit result archiver. This file actually later got moved to its own plugin, the JUnit plugin, but at this point it was still in core. So what is this matrix aggregator and how did we deal with that? So this is matrix project plugins. Let's open that up and we'll take a look at this interface. So we have matrix aggregatable, right? Written by Kosuke Hudson 1.115, so a long time ago. This is a definite anti-pattern. So any kind of like required marker interface is a bad idea. Like you should never ever do this. So you should never have cases where here, if you look at the uses of it, so basically this is saying it's going through all of the publishers and stuff attached to a build, and it's saying if any of them are able to pull in results of some kind from matrix builds, you know, like builds on Linux, builds on Windows, or something like that, then we're going to aggregate all of those reports into the master project at the end of the build. So that's the purpose of this.
Long time we were using it method to extend the interfaces, but since Java 9 is not no longer required, I suppose it was the only case of such marker interfaces.
No, unfortunately, it's not just a marker interface. It has this method in it. So you see, it actually has a method which has a signature that links to other things in the split plugin. So So basically, there was this switch in matrix build that said, if a given publisher implements this interface, then behave in one way and call this method on it. And if not, then behave in another way, which is to say, don't aggregate. This instance of this is the root of all of our problems right here. So basically, if you find yourself doing something where you have to check instance of, then you've just basically screwed someone 3 years down the road from trying to refactor your code. So don't do that. And the question is, well, how do you deal with that? In the case of a split from core, well, we can hack around it because in this case we just said, well, but in the special case of JUnit result archiver that I removed this method declaration from, we'll deal with it separately. So in this case, we're able to hack around it just for core because this plugin can depend on core, and so it could invert the dependency basically. So now instead of JUnit result archiver declaring that it's matrix aggregatable, the code that's checking for matrix aggregatable has a one-off case like, oh, for legacy reasons, JUnit result archiver is grandfathered in. This is a mess, obviously. So again, you don't want to get in this situation to begin with, but if you do get into it, then what you really want to do is do things with extension points, and that's the proper way to do stuff. So we actually had this. We actually had this matrix aggregator type, which has also been there for a long time. But this used to be not an extension point, just a sort of internal placeholder class used by this API. I have a pull request that I've set up to break another dependency, bad dependency that we didn't want. And the idea here is that we're taking this matrix aggregatable and turning it into a genuine extension point in its own right. So now, instead of being forced to implement this interface on things which may not even link against it, or you may not have that dependency on the matrix project plugin, because we want to be able to have optional dependencies on this plugin, so you don't pull in a huge set of unwanted plugins, including a brand new top-level project type, just because you want to integrate optionally with it. So instead of that, we're going to have this extension list lookup. And so the idea here is that anyone can add an extension anywhere, and they need to be able to, that extension needs to be able to link against matrix project plugin and against the thing that used to implement matrix aggregatable, but it can be in a separate place. So let me find here's a downstream patch using findbugs plugin. And so here we're no longer implementing this interface. We're not picking up this as a overridden implemented method. Instead, we have a separate extension point that acts as a bridge, and it says, like, if we're looking at a build and it happens to have findbugs publisher, then here's the implementation of how to bridge those two plugins together. But the critical thing here, and so this implements a newly defined extension point. The critical thing here is that it's an optional dependency. That means that if matrix project is not installed, this type is unloadable from this plugin's class loader. Thus, this class cannot be resolved. Trying to load it results in no class def found error. And presence of optional equal true means that Jenkins core, when it's loading all of the extensions, it catches no class def found error. It says, oh, it's optional, no problem. I'm not even going to print a message. I'm going to totally skip this.
Won't that mean that it seems to be an internal class of some other class?
Yes, it is nested, but it's static.
Okay.
So static basically means from the perspective of a class loader, it's totally unrelated to the other class.
So
Thinking that the import statement or something.
No.
like that.
No, from a bytecode perspective, it could as well be in a different source file or anything. Yeah.
accepting definition of the class, it's safe to define the fields of the class required and classes in method names and but if you just define a class field within a method, for example, matrix attributable within create applicator, it won't guarantee that class loading happens properly. You know that it even without the plugin.
Right. So there's some subtle points when you're using optional dependencies that you have to be able to guarantee that the no class def found error on this type will be thrown when loading this class, not just when using it later. So it has to be thrown during class resolution, not just during calling methods. So that means you have to use at least one of the types from the upstream plugin in
Or
your
a
class
static-
signature or method signature or
or
something.
a static constructor or something that makes it call.
Something, yeah.
So the constructor
Yeah,
is not going to fit in this case.
Static initializer, I think, will, I believe. But if in doubt, you try it. Like, if in doubt, go like
I've
this.
seen code from Jesse using a static initializer to throw
Yeah.
something.
But I've also gotten it wrong and had it cause like, showstopper bugs getting reported in Jira with like 37 votes. So like basically, yeah, you have to actually test it if you're not totally sure you know what you're doing. You have to test, load up the downstream plugin, go to plugin manager, disable the upstream optional dep, restart Jenkins, and make sure everything is survived.
I don't think you can right now for the UI.
Okay, yeah, there's some sort of UI bug that blocks you from disabling the optional dep.
Is there a way when?
But you can, if you need to, you can get around that by, for example, just touching the .disabled file on disk or deleting the upstream plugin.
So what's maybe important to know is that optional dependencies of any given plugin will be made available when you just debug the plugin.
Yes.
Yeah.
So in the typical, I'm developing a plugin and I have an optional dependency case, that dependency will be provided and you will test the full functionality of the plugin rather than the reduced set
Yes.
that you also claim to be compatible with. So that makes things a bit more difficult.
That was my question. It's HPI giving us an option to exclude the optional dependencies.
No, currently HPI run will include all of the optional dependencies. So you can test integrations, but there's not currently a mode to specifically exclude the optional deps to make sure those work.
It's not a big deal to implement it.
Yeah, it could be implemented.
Well, you were doing latest enablement?
That's cool. Why not?
And the same is true of Jenkins rule tests. Those will run with all of the optional dependencies present. So, and currently there's no, as far as I know, there's no way to get around that. You would need to have a new test framework, basically. Maybe acceptance tests, I suppose, could be used to get around that, but basically it's a good idea to do a manual test before you release any kind of change like that. So in summary, marker interface is bad. Bad. Use extension points instead so that any kind of bridging functionality, any kind of optional functionality you want is registered as extensions that can be factored out into separate classes. They can be made optional. You can put them wherever you want to put them, wherever it can link, and so on. So that's pretty important. But when you're dealing with legacy code that has these methods in it, you just have to be creative and try to figure out some way to get around it. So sometimes it's possible to work around these things using Java reflection. Ugly, but it can work. But there's no guarantee in general. Sometimes you just have to break compatibility and and try to update all the clients. Anyone have any questions? I can't think of anything off the top of my head about splitting plugins. Oh, what I should just say, Jenkins will, or the Maven compilation will let you know, obviously, because of Java type safety, if you accidentally have a reference to the removed plugin left in the core source base, which is helpful, and you need to do the same kind of refactoring to get things out of tests. It's possible to declare test scope dependencies on plugins from the Jenkins test module, but really kind of want to avoid it if possible. So we have, for legacy reasons, we have a few cases where we have a couple of these plugins that we're actually linking against in tests, but that's something we want to get rid of, and we don't want to add any more examples of that. So you really want to get all compile time references to your plugin out. Again, the Java compiler will help you remember if you forget about something. But it is important to make sure to remember to look for every possible resource, because it is very, very easy to forget some parts of those. I can't remember if it was in here. I think it was in, I have done this at least once with the Matrix project. Well, it's not going to be so easy to find in the history, I think, but maybe if we look in just the history of this project and go back to the very beginning, you'll probably see some examples of things that I forgot to move that I should have moved. So it's going to be commits, yeah. 639, wait, okay. Is there a quick way to jump back to the beginning? Let's see, it's 10 at a time. No, it's plus 69. If I do like plus 600, does that do anything? Yes. All right. Thank you for URLs. Okay, so actually, in this case, so that's interesting. In this case, I actually imported the history from the plugin. So if you look at some of these commits, well, first of all, this goes all the way back to Subversion days. So we have the reference to the Hudson Subversion server, but this originally committed as, I actually did, I can't remember which git command it is, but there's some git commands you can use which will take a subtree and import its history into a new repository. So I actually did this so that if you're looking at some really old historical change in the plugin and you want to know why it's there, you can just go back to Jenkins and look up that commit ID, and you'll see the original version of this. You'll see it was added to Hudson 1.3.12, and and you might see some changes to classes that were outside of this plugin or to other things. So that's useful metadata to keep if you can. It's a little bit more of a hassle to preserve all of that, but Matrix. So this was April 14th, 2014. But if you can do it, it's a good idea. See if we can dissect our way up to around where the split was, 2014. A bit older than this. Okay, so core dependencies. This is what I was talking about earlier, where you have to make sure that before releasing the plugin, you have to depend on a release version of core or Matrix or Maven release plugin will complain. And I think, okay, so that's after this. I think at some point I forgot a bunch of resources No, I can't find it. Maybe it took a long time before I actually even noticed. Basically, you need to really be careful to see that every kind of resource that was associated with your plugin also gets moved. If you look around in history, you'll find a few examples where this got forgotten. And that causes all kinds of mayhem, because sometimes it will sort of work for a while, depending on what version of people's core they have. It might look up the resource by the same resource path and still work, but you can get weird class loading effects and things like that. So it's important to look, to look for tests that even mention keywords used in the plugin you're using, anything potentially related, and then every package that you're moving, look in source main resources and source test resources for similar packages that might need to be moved. If I remember right, this this library didn't get moved in the this library didn't get moved at the right time, I think. Even tags a second. Load, aggregate field tests. So there are actually some test utilities. Yeah, here we go. And we found the fix up commit here. If you go to this commit, you see that I had accidentally left this particular resource file behind in core. I can't remember exactly what the impact of that was, but it was pretty bad. Like maybe it caused automated tests were still passing, but then it was throwing errors at runtime or something like that, and people are reporting problems. So so that means you need to move stuff. I think what I might have had to do is actually rename some files into a new package or something like that and leave behind a stub for the original. But just a reminder to look for all of those things wherever they might be. And same for any kind of POM dependency. So I mean, in this case, this is like pure plugin functionality here, but some things might have been pulling in some kind of library that wasn't actually used anywhere else in core, and that would be something that you'd want to move to the plugin POM. So look for third-party libraries in your sources, and I mean, you probably notice that when you're extracting the plugin, because you might not. Well, no, you wouldn't, because it would still be picking it up from core. You really need to look for any kind of third-party libraries that might have been specific to this plugin that should have been moved with it. I think that's it. Anybody else have any further questions?
One question about more complicated cases. If you want to decouple code, we just split it across Jenkins core and Jenkins models. What would be the best strategy in this case?
So that's splitting code across Jenkins core and modules.
Yes, so I can provide several examples, but actually it's all agent installers. We have some weird things like start, installer, etc., which really shouldn't be a part of the core. And also Windows service in the model, which requires regular updates and it causes much effort.
Yeah, so like upstart slave installer module.
Yeah, actually there are almost 10 whatever installer modules.
Yeah.
All of them are not really maintained.
Yeah, so for anyone who doesn't know, because it's kind of obscure, there is a feature of the Maven HPI plugin normally used to build Jenkins plugins that lets you declare this packaging called Jenkins module. It basically has structure to a plugin, but the difference from a plugin is that rather than being something a user installs and manages from plugin manager and update center and all of that, It is packaged directly into Jenkins War. So you can see here, Jenkins War has a dependency on this artifact, and in a actual war file, these, if I remember right, these appear. Yeah, here it is. Upstart slave installer 11.jar. These appear in webinflib, so they're basically just like in a traditional, Java EE war. It's just part of the main class loader of the application, right alongside. It's right here alongside Jenkins core and everything else, and all of the libraries Jenkins core brings in. So they are built against Jenkins, and they're supposed to be structured like a plugin, so they can use Jenkins APIs. Jenkins core cannot refer to the module, so it's a one-way dependency, just like in a plugin, but it's physically packaged inside the war and not managed by a user. The only reason to do this is if, for some reason, that functionality cannot be loaded as a plugin, either because it has to be present earlier during Jenkins startup, in case it has some, sometimes things will have a meta services extension, distinct from a Jenkins extension, that need to be loaded, especially early in the startup sequence. Or do we have anything here? And I have some annotations. Or because, for whatever reason, the classes it exposes have to be part of the same class loader as Jenkins core. Those are the only legitimate reasons for these things to be in modules.
Technical reasons.
Yeah, technical reasons. Here it's just, okay, it's an extension. And the question is, why is this in a module at all? And I don't really know, because, slave installer factory, this is also a module, but there's a slave installer module. Okay. Buildable. So this defines this extension point slave installer factory. And that's called somewhere from various points. Why this is packaged as a module, I'm not really sure, because I'm guessing that it's only actually used, computer listener impulse. You can see where it's used is an agent comes online, and it goes and offers to run something on the agent to let the user make that agent be permanent rather than one-off like JNLP agent. Registers Windows service or something.
My best guess is that the entire model system has been created as a first attempt to do pluggable core components, but it wasn't completely finished.
Yeah.
So.
Yeah, in this case, I don't see any particular reason why this needed to be a module at all, and I suspect that the API module and all of the implementations could simply be made into Jenkins plugins, put in the setup wizard, and that's that.
I was considering it for the Windows agent installer model, but after some investigation, the only thing I see is to just detach all models for agent installers and also edits from the Jenkins core. Otherwise, it's almost impossible to do that.
Yeah, so Windows slave installer, same kind of case. There's no real reason why this is a module as far as I know.
Yeah, so there is some reason for that, just because you have directly Windows support by default when you install Jenkins.
Well, yeah, okay. So in terms of installing functionality by default, that's something that we handle in the setup wizard and for compatibility in the detached plugins list. Yeah. But
generally, it should be a plugin, definitely. But the problem with that is Windows slave installer it uses slave installer, so you can just move it to the plugin because there are dependencies
Dependencies from what?
from slave installer. So you can declare the dependency on the model in the plugin, but in such case you bundle the particular version and it's hard to upgrade the stuff.
Well, I'm saying slave installer itself, as well as all of the implementations like Upstart in Windows, these should all be plugins. So none of this stuff needs to be modules at all, because it doesn't need to run during startup and it doesn't need to have a special class loader as far as. So all of these things could become split plugins, basically.
And if you talk about more low-level models, for example, instance identity, which has been used widely.
Yeah, an instance identity, again, I don't know of any reason why this needs to be a module. So this is something that basically it serves up, it serves its main purpose. It has an API of sorts, which is instance identity.get public and get private. So a few plugins call these methods. By basically you have to declare I think you need to declare like a provided dependency in your POM or something in order to get access to it. And at runtime, it serves up this HTTP header on all web requests that lets REST clients do various things, identify a particular instance. But to the best of my knowledge, there's no other particular reason why this was ever a module to begin with. It could have simply been a plugin, just like any other plugin. I think that's probably also true of SSHD module, but I don't know for sure.
The problem of all these things is that they are implicitly used in Jenkins code. So even if Jenkins code doesn't use these classes, there may be some repetition code or whatever. And for things like SSHD, it's really risky.
I don't think SSHD is. It's Danny provider. I don't even know what that is, but
it's just a magic
source of instance Danny. So this is an extension point, and I guess it's implemented by the module. But that's fine. So it's not used directly from core. It's only used implicitly via this interface. So as long as the plugin was provided, then you would have an implementation of it in the system. And you'd have to make sure that the whatever method whatever is calling this, checks for null somehow, so that it's any provider. So there's a key there, get public key. Oops. So this is okay. So all this stuff internally is calling get, which may return null. So basically, it's already set up to handle the case that instance identity is not there for whatever reason. I mean, currently that should be impossible because it's not module, but if you make it into a plugin and it's not installed, then definitely this would return null. But whatever code is supposed to be checking that is already checking for null. So. Theoretically, so. Yeah, so all of those things, all of these modules could probably be split out the same way as in the other code. It's actually easier because we already know there's no Java level references from core because that's physically impossible. So it's just a matter of moving them into a plugin and testing the result basically and making sure that it still works.
Stuff like Ruby references is still possible.
Sure.
Possible.
Yeah, untyped, run-type references are always possibilities, so you need to look around, do text searches, and see if there's anything that looks suspicious. Anything else?
how do you deal with splitting up messages properties?
Good point. Messages.properties. So, yeah, that's a really good point because they've also been burned by that and other sources. Showstopper tickets on Jira, they're not reproducible in the functional test environment. So things you don't notice until it goes live. And several days later, people start having their systems explode. So if your plugin if the plugin that you're splitting out entirely owns some package, like here I'm in Hudson Matrix package. So everything that used to be in the Hudson Matrix package in core obviously is being split into the Matrix project plugin because that's what the whole plugin was about. But in other cases, if I have any examples in this plugin, probably in JUnit plugin. In other cases, there may have been sort of isolated classes scattered around in other packages and so on. And messages.properties generally refer to classes in the whole package, all over the package. And so what you need to make sure is that you are not defining a messages.properties in your plugin that has the same resource name as something in Jenkins core. So if you have to split up a messages.properties with some of the keys staying in core and some of them going into a plugin, you have to rename the ones in your plugin. Yeah, you don't have to rename the keys, but you need to rename the messages.properties and actually put it into a different package altogether.
There is another potential problem. We started restricting messages properties only this year, but before that, this class was actually a public class. And it was possible to use, for example, the force message properties from plugins, and we had some best use cases for that.
So the problem is how messages properties works. A class is generated from that in its package with basically getters that either return the translatable string or just a string for the current locale. So if you have Hudson tasks messages properties in core and Hudson tasks messages properties in the plugin, then that's the same class. So you need to move it to a different package just to prevent problems there. What the keys are called doesn't matter.
Right. Yeah, it's both the Java bytecode for the generated messages.class that gets created, and at runtime it's loading the messages.properties resource, so it needs to know which one to load also. So for both reasons, it has to be unique. So here's actually an example. We split the mailer plugin. As you can see, the main thing that got split was hudson.tasks.mailer. This shared a package with a whole bunch of totally unrelated stuff that was left in core. So if I had left Hudson tasks messages.properties in this plugin with just some key, then this will explode big time in production. You'll basically blow up. Yeah, that's a technical term. So what you had to do is create a new package that's well, actually there were some other stuff that wound up getting put in this new package anyway, but one way or another you have to create a totally independent package so you can be sure it's used only by this plugin.
And then you change the references to it in the source code?
Yeah, so if we
or the imports.
Yeah, here let's look at one of these messages. So failed to access build log. We'll look for the use of that. So this is found in mailsender.java and Hudson tasks. So the Java class was in the original package, but it has to access messages.properties in the refactored one. And in this case, it's just using an unqualified class name, but
The import.
But you can see that we have to have an explicit import statement to make sure that if I took this out, There will be a
Then
messages,
you
but
get the one who's goal.
yeah,
All right.
if I forgot that import, then I
It
would,
would satisfy it from the packet.
yeah, it would
But
find
it doesn't
messages
have
from
what you
core, but it would say I can't find symbol. This is where you get screwed up because remember I said that you have to do that two-step dance where you release the version that depends on the old version of core, then you release core, and then you release the plugin depending on the new version of core. So you cut the first plugin release, you're depending on the old core, you forgot to add the import statement, this method still exists in the old version of core, this compiles, your tests run, everything looks great, and then a few days later people start screaming, and you don't notice until you update the core dependency.
So
You
it's
screwed
not
up.
safe is it to delete digital messages at all? Because there is no guarantee that there are no usages from other things.
So how safe is it to move the keys into a new
No, so
property?
you created new messages in new package.
Yeah.
But at this point, you still have
Could be
messages.
the old messages there in rather than doing move just to a copy. Isn't that what you're saying?
Yeah,
You
so
could,
just moving to is dangerous because messages used to be a part of the core API a long time.
Right, but so I think you said that we're no longer exposing messages to properties.
They're restricted,
Yeah, it's restricted.
but they were restricted only in 2.x something. And all functionality we decouple presumably exists in the core from very beginning. So you cannot guarantee that the plugins building with the dependency actually get restricted.
Right, so that's a good reason
Well, over
to
time, plugins should get new core dependencies, and then
we'll pick this up.
at compile time,
So
have problems picking up those keys.
Exactly. So if anyone has a sufficiently new core baseline, then they're not at risk. If they don't, then it's probably unmaintained anyway.
efficiently is 2.40 something database.
All right. Well, most people who update plugins are on 246x or newer anyway, so as we found out. So it's fine as a core baseline. But yeah, if in doubt, it's possible to, again, grep GitHub for the keys that you're deleting and make sure that they're not actually used anywhere. For someone to use it, they would generally have an import statement that would be like import such and such dot messages.
Another way is to declare build with the latest version of Jenkins code in a build plugin Jenkins file, just to be sure, but it will be always a kind of boilerplate for you because whatever we change in Jenkins code, the completion rate.
Yeah. Yeah, so another plugin, yeah, that doesn't help the person who's doing the split though. But you're talking about other plugins that might be affected by splits. Yeah, it's a good idea to test against to recompile against new versions of core, just to make sure.
Will you override 236?
236?
So 246 is the first of the
246x. Yeah. We'll have this at restricted that
So it's
prevents abuse.
2656 is the PR.
Yeah, definitely something to pay attention to and worth doing an extra set of sanity checks and searches and things for this. Yeah. At the same time that you're looking for other resources that you forgot to move. Yeah.
Well, I mean, this should make it easier to split the plugin off, right?
Yeah, it makes it safer.
Because if you keep using messages, it'll just blow up.
Correct.
Right from the start.
Correct. Now, a lot of plugins use messages.properties from other plugins in test code because they want to verify some message appears during a test, and that's fine. I mean, if it gets broken, it's just test code. So you can update it.
But probably we should make all generated code restricted, including Groovy classes, etc., because they effectively involve the same risk.
Well, Groovy classes, I mean, it's up to the author of that class whether it was supposed to be an API or not. I mean, best would be to just get rid of all of these remaining, was it 3 classes?
Plus one.
Yeah. I mean, there's not a whole lot that's still actually written in Groovy and Core, so we might as well just make that Java code and simplify our build process.
We have generated code from concat.
Yeah, so that's generated sources, Antler, label expression, Lexer, and stuff. But I mean, it's really unlikely anyone is referring to this stuff because there's no reason for it. So, whereas we know people have actually, but we know people have actually used messages methods from other plugins. It's a real known problem. So.
Great.
Any other questions? Anybody watching online, or are there any chat messages, questions, anything?
Thank you, Jesse.
All right.
Thank you.